What's up, everybody? In this video, we are going to explore the built-in LED matrix on the Arduino Uno R4 Wi-Fi board. We'll cover an overview of Arduino libraries and walk through some example code to get you started. When you first started using your Arduino Uno R4 Wi-Fi, you may have noticed there was a fun animation that ran when you first plugged it in. As soon as you uploaded your first sketch, the animation disappeared. In the following set of lessons, we are going to explore how we can turn on and off pixels and make animations. I found that playing with LEDs can be really fun as it enables you to visualize things relatively easily. Before we dive into the code, let's talk about Arduino libraries. Libraries are pre-written code that extend the functionality of your Arduino sketches. They save you time by providing ready-to-use functions for various components and features. When you explore new components that you can use with the Arduino, many of them come with a library of code that you can use to make it easier to get up and running with a sensor. The Arduino Uno R4 Wi-Fi comes with a library called the Arduino LED Matrix Library that will control the onboard LED matrix. To use a library in your sketch, you need to include it at the top of your code. When you do this, you write #include, and inside quotation marks, you write the name of the library. You can load multiple libraries in a single sketch, so if you're mixing components that each have their own libraries, you add a line to each library at the start of the sketch. Let's look at a simple example to display a pattern on the LED matrix. Start by opening the Arduino IDE and create a new sketch using our template we created in Tinkercad. Fill out the information in the header of our code. Update the program name and description. The program name is LED Matrix, and the description is a sketch where we will render 2 frames to the Arduino LED matrix. Next, we'll include the library and create an instance of the LED matrix. Beneath the comment that says declare variables and load libraries, write #include space quotation mark Arduino _LED matrix.h quotation mark to load the library. On the next line, add Arduino LED matrix space matrix semicolon. This line of code creates an instance of the LED matrix. Here, matrix is an instance of the Arduino LED matrix class. This line creates a specific object that we can use to control the LED matrix on our Arduino board. Instance? Class? What am I talking about? A class is a blueprint that defines the structure and behavior of an object. An instance is a specific object created from a class with real data and behavior. In Arduino, defining a class allows you to model complex behaviors in a reusable way, while creating an instance lets you work with specific objects in your program. What that would mean is if I have multiple LED screens that I wanted to control, I could create a separate instance for each, all using the same class. Next, in the setup function, we need to initialize the LED matrix. Inside the curly braces of the setup, type matrix.begin, open and close parentheses, semicolon. Let's have a look at this line of code. Matrix is our instance and begin is a function. But where did the function come from? When we load an external library, when the code compiles and is uploaded to the Arduino board, it imports all of the declarations and definitions, including functions from the library. Most libraries should have a reference that shows you what functions are available, how to use them, and example code. Now, let's create a simple pattern to display. The LED matrix library for the Arduino R4 Wi-Fi works on the principle of creating and loading frames. A frame is essentially the image that is displayed at any given moment on the matrix. We can add multiple frames to create an animation. In our program, add the following code. I've pasted the code in the YouTube description to make it easier for you. Let's have a look at how we declared a frame. We just created something called an array to represent our 12 by 18 matrix. An array is a data structure that can store multiple values of the same data type. It is like a list of items where each item can be accessed by its position or index in the list. In our case, it is a series of ones and zeros that refer to each individual pixel. Anything that is a 1 will turn the LED on. and anything with a 0 will turn the LED off. There are some other elements we haven't used yet. Byte is a data type that stores digital information as 8 bits. Using bytes isn't the most memory efficient way to store data for the Arduino, but it makes it easy for us to know which LEDs are on or off. Next, we have heart. Heart is the name of the frame. We can change this to be descriptive of whatever we want to use. Then we have 8 and 12. They are the height and width of our LED matrix. Now, in the loop, we will display our frame. Type matrix.render bitmap, open parentheses, heart, 8, 12, close parentheses, semicolon. Now, we are calling the render bitmap function from the LED matrix library. When we call it, we pass 3 parameters: the name of the frame and the height and width of the LED, so 8 and 12. Upload your code to the Arduino and see what happens. You should see a heart appear on the LED matrix. Awesome! We just displayed a custom frame that we created on the LED matrix of the Arduino. Let's do something else. Copy the code we used to make the frame for the heart. Paste it below the heart. Change the name from heart to squares. Update the 0s and 1s to make 2 squares, one inside of the other. I've pasted the code in the YouTube description. To make it easier to see what will be displayed, if you type Ctrl F on a PC or Command F on a Mac and search for 1, this will highlight the pixels that will be turned on. Now in the loop, copy and paste our matrix.render bitmap and the delay. Change the name of the frame from heart to squares. Upload your code to the board. Now every half second, you should see the pattern changing from the heart to the squares and so on. Awesome! We just created a basic animation based on custom frames that we created. Feel free to experiment with your own patterns. At the end of this video, you should understand how to load a library of code into an Arduino sketch, create a frame, and display it on the Arduino LED matrix.